Next up, I do want to take direction into account. Find a parametric equation of a line. I need it to run from A to B. They also write parameterize this line. That means give me direction. This one I'm going to show you with a graph. Well, to find a parametric equation of a line, what I need is a point and a vector. It doesn't matter which way it runs, except they say from A to B. So V is fixed. V is actually 0 minus 1, 1 minus 2, and 3 minus 0. There it is. Got it. And when I write my vector equation, now I really don't have to, but I could jump straight to the parametric form. I could say x equal, and this is going to be my initial point, plus the I component. Y is 2 minus t, and z equal simply 3t. You could also, of course, find this first until you get the hang of this if you wish. The vector form gives you everything that you need, and just the I component, the j and the t. Now, here's the deal. I need t to get me the direction that I want. If this is how you did it, 0 will get me on the first point, and all what you have to do is match one point. Look at the x, for example. What value of t would make that a 0? 1. That will take care of the trick. If I look at how this graph looks, the initial point is at 1, 2. That's A. B is at 0, 1, 3. Right? And my parametric equation, if I put t equals 0, it will get me there. If I put t equal 1, it will get me there. What that does, that allows me to write this with a direction from the first point to the second point. Right? Oops. Those are angles. And if I look at the second example that I have, same deal. I would say, well, let's find V. V is end minus beginning. 1 minus 2 is a negative 1. Negative 2 minus 5. Oops. Negative 2 minus 3 is negative 5. And 2 minus 5 is negative 3. Okay. I'm losing my touch. And, of course, R equal the initial plus t times negative 1, negative 5, negative 3, or simply R equal 2 minus t. Of course, you don't have to do this. You could jump straight to the parametric form. And from this, you could say x equal 2 minus t, y equal 3 minus 5t, and z equal 5 minus 3t. And I need to give it direction. If I let t equal 0, based on the way I'm doing this, 0 for t, I'll get this point. And match one of them. Any one of it must have t in it. 2 minus t. What do you substitute in for t to get a 1? Well, obviously a 1. Now, watch how this works. If I look at the initial point, the initial point was at 2, 3, and 5. That's A. The terminal point is at 1, -2, 2. Well, look what happens. If I take t to be 0, well, obviously I'm right there. 2, 3, 5. And if I let t equal 1, I am right there. Pretty much what that does, that allows me to write this as a vector in the direction that is desired. That's a must for what's to come. So for a plane, we also need a point and a vector. For a line, we need the vector to be parallel to the line. A plane in space is determined, I should have typed this, is determined by a point in the plane. And a vector, we're going to call the vector not v, we're going to call it n. That is orthogonal to the plane. This orthogonal vector and is called the normal vector. And normal vector is a vector that is perpendicular. So we start off by let a point be on the plane, any point. Arbitrary point in the plane as well. And let r sub 0 and r be the position vectors of p naught and this arbitrary point. So I'll show you a diagram of what that means and how that works. Then the vector r minus r sub 0 is represented by p naught to p, that vector. Let me show you really quick what we're talking about. Here's a diagram. If I pick r sub 0 or p sub 0 to be right there, and let p be on the other side so you could see it. This is x, y, z, and this is x sub 0, y sub 0, z sub 0. So what I do, I say, well, let's make this vector from the origin r sub 0, and let this vector be r sub 1. Or r, I'm sorry, just general r. I don't give it a subscript. Now, if I really want to look at this vector, from p naught to p, if you remember when we did vectors, this is really r minus r sub 0. Because those are not tip to base. I could say easily, this plus this, no, I'm sorry. I could say this plus the resultant equal that and solve for it, if you call this the resultant vector. in case you're not seeing it. So if you're thinking in terms of resultant, you could say the resultant vector, you could say R is R sub 0 plus, right, the sum of those vectors tip to base, and all what you have to do to get R, subtract those from both sides. And there it is. R would be R minus R sub 0, the resultant. Easy to see. Now, that is right there. The normal vector n is orthogonal to every vector in the given plane. N is orthogonal to the vector, oh boy, I'm sorry, to R minus R sub 0. So if I take n and I dot that with R minus R sub 0, that should be 0. Right? Remember, I'm going to let n equal a, b, c all the time, the vector. And R is really x, y, z. And R sub 0 is x sub 0, y sub 0, z sub 0. So what I know those two. And if I take n and I write it as a, b, c, and I dot that with R minus the difference of those, isn't that x minus x sub 0, y minus y sub 0, and z minus z sub 0 equals 0? Well, what does that mean? That means a times x minus x naught plus b times y minus y naught plus z times c times z minus z naught equal 0. And what that does, that gives me an equation of a plane. Equation of a plane with R naught in the plane and n orthogonal to the plane. So that's all I need. To find an equation of a plane, I need a point on the plane and the orthogonal vector is actually perpendicular to every vector on the plane. And that's pretty much the big secret. All of this work to get that equation. And if I look at the next set of examples, find the equation of a plane, and through the point, they gave me the point. Very good. And they gave me my normal vector. It's perpendicular. So the point is really negative 1, 3, 5. And the normal vector is 3, negative 1, negative 2. It is as simple as me saying, well, no big deal. A into x minus x1 plus, it's a minus, b times y minus 3, c times z minus 5 equals 0. That is good enough. You could, of course, simplify and say 3x plus 3 minus y plus 3 minus 2z plus 10 equal 0. Or you could simply say 3x minus y minus 2z equals, what is that? 3, 6, 16, negative 16. That would be the equation of the plane. This point is on it, and this vector is perpendicular to it. So to find an equation of a plane, I need a point on the plane, and I need a vector normal to the plane. Here's another example. Find me an equation of a plane through the point. Again, they gave me the point. That's very good. That is 3, 2, 4. You could call it r sub 0 if you wish. That's perpendicular to the line. Well, think of it this way. If I want to find an equation of a plane, if I have a plane, and there's a line perpendicular to it, isn't any multiple of that vector perpendicular to the plane? So isn't my n really, and you notice they gave us the parametric form of a line. Can I read the vector out of that? Well, yeah, that's 2, 3, and negative 1. And once I get those, pretty much I'm done. I would say 2 into x minus 3 plus 3 into 2 into y minus 2 plus c into z minus 4 equals 0. That would be sufficient for a test. The back of the book will most likely simplify. (2x plus 3y minus z equal), that is negative 12, negative 8, that's an 8. There it is. That's a plane that contains the following point and perpendicular vector to it is that. Another example. A point is given. The point is given all the time. That's no big secret. Parallel to this plane. Parallel to a plane. Let's see. I have a point on a plane. Of course, I'm graphing those trivial horizontal so you can see it. Assume this point P0 is right there. I want to find an equation of a plane through this point, but it's going to be parallel to this other plane. Well, think about it. If I need a vector perpendicular to this plane, isn't that automatically perpendicular to this plane? Well, since I have the equation for this plane, can't I say a normal vector is 2, negative 5, 1 based on what I just explained to you previously? And wouldn't that vector be perpendicular to both? So I could use that as my n and say, well, 2 into x minus 1 minus 5 into y minus 3 plus 1 into z plus 2 equals 0. Again, that's a fine answer. On a test, that's all you have to do. The back of the book will most likely give the following. So on the homework, you should clean it up. And that is 2x minus 5y plus z equal, the 2's cancel out, negative 15. That would be my plane that's perpendicular to this other plane. Again, during our discussion, if you bring this up, I'll be more than happy to go on that site and show you some of these problems. Almost done. I just want to touch on all ideas, all different combinations you could ever come across. And I believe that's it. Yeah, that's the last example. I want to find an equation of a plane, and they give me 3 points. Again, the graphing those is kind of hard to see what you're doing, but if you use software, and we'll be more than happy to show you. 1, 3, -2, 2, 1, 2, and 3, -1, 0. If you connect those, again, this is an infinite plane. This is just a piece of it. It gives you an idea of how the plane looked like. I need to find an equation of that. Well, we have a problem. They gave me 3 points. I need a vector perpendicular to those. How do I do that? Well, hey, guess what? If I call, and it doesn't matter which points you pick. If I pick, I'm not going to call it A. I'm going to call it vector P. I'm going to use this as the main point. I'm going to use this as the point with the 2 vectors. You know what I'm going to do, right? I'm going to cross those 2 vectors and end up with a vector that is perpendicular to both of those. And then that's going to be my normal vector. So to do that, I'm going to fix this to be the main point, because remember, the 2 vectors must share a common vertex. You could choose this, you could choose, doesn't matter. So I'm going to say vector P is going to be 2 minus 1, 1 minus 3, and 2 minus 2, and vector Q, so let's say this is P, this is Q, this is R, that'll be easier. PQ, let's see how I named them. P, where's R? 3, -1, 0. Okay, this is Q, this is R. So this is PR. Much easier that way. And what is PQ? Again, it must be the same vertex. PQ is 3 minus 1, -1 minus 3, and 0 minus a -2. And if I cross those, again, my own notation, if I take PR crossed with PQ, that's going to be my normal vector. Cross the I, that is -4 plus 16, that's 12. The J component, cross the middle, 2 minus 8 is -6. And cross the K component, -4 plus 4 is a 0. Hopefully I didn't make a mistake, but you get the idea. This is my normal vector. Take a point. Now I'm going to take this point and that vector, and I'm going to say 12 into x minus 1 plus a -6 into y minus 3, and 0 is not there. That will be my, so 0, right? 0 times, I should write it for the notes so you wouldn't be confused. 0 into z plus 2 equals 0. So that is 12x. Again, that's a fine answer right there. 12x minus 12 minus 6y plus 18 equals 0. That would mean 12x minus 6y plus 6 equal a -6. Of course, I could divide all of those by a 6 and say 2x minus y equal a -1. Again, that's all cosmetic work, but there it is. That takes care of it.